All right, we are in Chapter 2, Section 2, called Solving One-Step Equations. This is for Integrated Math 1 or IM 1. So just kind of my quick little tutorial here that I've been doing in all the videos. This is the assignment screen that you will see as a student, with the exception of a couple of things. So on the teacher preview, I don't get a due date. You will see one on your screen right before attempts. And then when you look at attempts, it'll tell you which attempt you're on. So I'm on number 1 of unlimited. This means I can go in and do this assignment as many times as I would like to do it. There is no limit there. The number of questions. So this particular assignment has 10 questions. It will have anywhere from 1 to 10 for your assignments. Grading policy, best score. So that always means, your best attempt is the one that you get to keep. And partial credit means, if you answer 1 of 10 questions, you get credit for the 1 question. This right here is just a reminder that we should always click the submit button in the bottom right-hand corner of our screen. So when I click start here, you won't see this on my screen because this is the other piece that the teacher preview does not have. But now you should see a submit assignment button on the bottom right corner of your screen. Even if you've only answered a single question, still click the submit assignment button, because this will make sure that we know you're working on it. It'll tell us what grade you have on it, and you can come back and do it again. It will also stop it from locking you out of everything else. Because if you don't click the submit assignment button and you just X out of the screen, or you go to the little home menu button that you'll also see here, it'll lock everything else and make you come back to this assignment. So it's, just to make sure that you don't get locked out like that. But also, we want to see where your grades are. We want to see what you've been working on. On the right side here, you can see that there's some tools. If I move my computer back here. So we have the explanation button. This will explain the exact problem that we are on. So it will give you the answer. It's going to take your attempt away, meaning it's going to put an X on it like you got it wrong. And you're going to have to come in on another attempt to try it again. Because it's going to give you the answer, so it's not then going to, let you come and type it in. But it is a very convenient tool. It's a very nice resource, because maybe the example that's a general example wasn't kind of good enough. You still don't quite understand what they're asking you to do on this exact problem. So you can go and take a look at the explanation and then come in on another attempt and try the problem. Okay, so the examples are pretty good. They give you an example of pretty much exactly what they're asking you to do here, so that you can go through and fill out the problem. If you need another example, you simply click here. It gives you a brand new example. It's not going to give you the same one each time. You can message your teacher so that they know. It'll attach this question to your message, and they can turn around and help you on the exact problem that you need help on. All right, so let's go ahead and take a look at some of these ones. So we have 7 equals x plus 4. So if we take a look at this, and I'm actually, there's a few ways you can do this. So if we look at some algebra tiles, and algebra tiles are, it's a tool that usually you have like on your desk and manipulative, but we can do this with drawings. So we usually have a square for our x, our variable, and then we're going to have, and I'll do this in yellow, I think is sometimes what we have it on the notes page. Yellow is going to be our positives, and red will be our negatives. And we always do this as ones. So you kind of split it up this way. So if I look at this and I say, okay, well, what do I have on the left side here? I have 7 ones. So I'm going to go 1, 2, 3, 4, 5, 6, 7. 1, 1, 1, 1, 1. And especially if you don't have color coding, put the positive 1 in there so that we can see that it's positive 1. And then on the left side of my equation, I have 1x, because that's all I can see. There's a single x. That's what this x means. And then I also have 4 positives, like this. So what I want to do, I'm going to line them out like that just to make them a little easier to deal with here. I want to get x by itself. That's always, always, always my goal. This guy needs to be all by itself. So in order to do that, I need to kind of do some inverse actions. I need to take these 4 and I need to do the opposite. 1 positive, 1 negative, that cancels. 1 positive, 1 negative, 1 positive, 1 negative, and last one, 1 positive, 1 negative. Well, if I take these away from the right side, I also need to take them away from the left side, because this is definitely a balancing act. You can't just take them away from one side and not the other. So they cancel out just the same way they did over here. And then we say, what are we left over with? So in this case, I'm left over with 3. So 3 equals x. So this is just, an Algebra Tiles method for looking at this. Algebra Tiles can definitely be very convenient when we're wanting to visualize our problems, because it definitely explains exactly what's happening. As we get to bigger numbers, they start to become a little inaccurate, only because it's very difficult to look at that many tiles. So this works very well for the beginning types of problems that we're starting right now. But once we start moving forward, we want to understand the algebra behind it. So if I kind of go back to the problem here, and I just take a look at it, we already know it's 3. X has to be 3. But if I look in here, this is a pretty simple one. If I say, well, this side is 7, and I have 4, I need to add something to it to get 7, well, it's going to have to be 3, right? Because that's how I get 7 here. So this one's not too terribly hard to just fill in and go, okay, I have to have a 3 for that x in order to make this true. But you can also use the algebra and say what's left over. So I would look at the x and say, I want to get it by itself. And just like I took these 4 away here, and say minus 4, minus 4. So I took 4 away, and I'd have 3 equals x, because 4 minus 4 cancels out. And these 4 of these canceled also. That's why I'm only left with 3 here. So here's the visual, and here's the algebra that goes with it. So either way, we get 3. And again, this one is pretty easy to look at and kind of figure out without all of this, but it's definitely helpful to understand kind of all of these methods. All right, let's go to the next guy here. Okay, so this one's a little bit more difficult to do with Algebra Tiles because I would have to have some decimals. Well, these don't work with decimals. So we can't use Algebra Tiles in this one. We're going to have to just use the algebra that goes with this. So we have v plus 3.9 equals 8.85. So just like on the last one, I'm trying to get v by itself. So if I'm adding 3.9 on the same side, I want to move that away to the other side here. So I'm going to subtract 3.9 from both sides of my equation. V is going to drop down because I haven't done anything with it. 3.9 minus 3.9, any number minus itself cancels out. And then we're just going to start subtracting here. Remember, there's a 0. I've lined up the decimals, and I kind of did that on purpose. So 5 minus 0 is 5. 8 minus 9, well, I'd have to borrow there, right? In order to do that, I get 9. And then 7 minus 3, I'd get 4. So in this case, I have 4 and 95 hundredths. And that's what V would need to be in order to add those back. And I can go back and I can check. If I go 4.95 and I add 3.9 to it, I should get 8.85. If I don't, I need to go back and make sure that I did my work correctly. So in this case, that does check. I do get that 8 and 85 hundredths. So 4.95, check. All right, next. Okay, so this one, because it's negatives, is not always the easiest to think about or kind of picture. But I like using a number line when I'm doing these ones. You can also do the algebra tiles, but I do like the number lines. So in this case, we have -6 here. That was our kind of answer. And then we started at a number and we took 3 away from it. And that landed us at -6. So if I took 3 away to get here, then I need to add 3 back to figure out what the number was. So if I go back 3, then this is what the number had to start with. So just kind of a way to kind of go backwards and think about that. But you need to make sure you understand, I had a number, which we now know is -3, and I took 3 away, which made me get over here. So if I want to go backwards, instead of taking them away, I have to add them. And if we look at the algebra that goes with that, that's exactly what we're going to do here. So if I want to get W by itself, I need to undo what's being done to it. I'm subtracting 3, so I'm going to add 3 to both sides. So that's exactly what I was saying here. So 6, and then remember this is the addition. Oops. This is addition. This is subtraction as far as direction. So that's why we want to move toward addition. We want to add 3. So this would give us -3, and then W because the 3's cancel out. All right, -3, check. Continue. And again, you can use Algebra Tiles on any of these if you want to as well. There's multiple ways to do this. When it's integers, you can't really, when we have fractions and we have decimals, that gets quite a bit harder to use Algebra Tiles on. So we do get a little limited with that kind of stuff. All right, so now we have U plus 7/8 equals 1/4. So there's 2 options. You can either completely eliminate the fractions if you know how to do that, or you can turn them into like fractions. To completely eliminate the fractions, if we did that first, what we need to know is the lowest common multiple for 8 and 4. Well, the lowest common multiple of both of those is going to be 8, right? So if I multiply everything, the entire equation by 8, every single thing is going to be multiplied by 8. Then what happens if I have 8 times U, I have 8U, plus, now in this case I have 7 times 8, and I'm going to write this out so you can see it, over 8, equals 1 times 8 over 4. So, and I wrote this out just so that you could kind of see the canceling happening. 8 divided by 8 cancels, and I just have 7. Well, 8 divided by 4 is 2. So I just have 1 times 2, and I get 2. So I've completely canceled the fractions. And now I can go through and start doing my PEMDAS steps. Well, not really PEMDAS, it's solving steps, so it's kind of backwards on PEMDAS if you've learned it that way. So we're going to do addition, subtraction first. I'm going to subtract 7 from both sides. The 7's cancel. 2 minus 7, so remember if we look at a number line here, I have 0, I have 2 here, and I'm subtracting 7 from it. So I need to go the 2 here and then 5 more here to go a full 7. So it's going to be -5. So another way to look at that is I subtracted 7 minus 2 is 5. 7 is bigger, meaning there's more of them, so it's -5. And then I would divide by 8 on both sides to finish that off. So I'm going to just be lazy and just say U equals -5/8. So this is one method. It's not the only method, but it's definitely one method. So I know, I'm going to go ahead and click on this. It's going to be 5/8, but let me show you the other way, because this kind of depends. This one might be a little bit more advanced for some students, this method that I just showed you. So you can also just combine like terms by creating like fractions. So in this case, I just say, well, I want to get U by itself, so I'm going to subtract 7/8 from both sides, like this. U, and then 7/8 minus 7/8, even though, yeah, they're a little funky, they're still the same number, so they cancel. The only thing over here is I have 1/4 minus 7/8. Well, in order to actually subtract these, they have to be like terms. So I can change 4 into 8. and that I had to multiply by 2 to get there. So I have to do the same thing on the top. I have to multiply by 2. So now I have 2/8 instead of 1/4. It means the same thing, but you need to convert that into like denominators before you start subtracting. So now I have 2 minus 7, which we just did. That still gets me -5. And then the 8 comes over. When you're subtracting or adding, the denominator stays the same. So that doesn't change. So we just arrived at the exact same answer by using fraction addition and like denominators. So just depends on the method you like. If you like eliminating the fractions right away, you can do that. But adding and subtracting fractions is not too terrible as long as you understand how to make them like fractions. All right, let's go ahead and click check there. Okay. All right, so we also have this one, and you can use Algebra Tiles for this. I don't particularly think they're as clear when we're using multiplication and division, because sometimes students get a little confused. But I can show you what it looks like really quick. So with this one, remember the variable is shown with a rectangle. Oh, I'm going to draw that a little smaller. So we have a rectangle here. So how many do I have? I have 10 of them. So I'm going to draw 10 B's like that. Jeez Louise, I keep trying to draw those huge. 2, 3, 4, 5, 6, 7, 8, 9, 10. So there are all my B's. There's a ton of them there. Equals 5. 1, 2, 3, 4, 5. So this is where it gets a little confusing if I'm trying to use the algebra tiles with division, because in this case, every single one of the B's needs the same number of tiles. So if I start trying to divide this up and I go, well, each one gets 1, well, I run out right away, right? So instead, it's actually going to be 2, like this. So every 2 of them gets 1 tile. What that means is I'm cutting them in half. I have to divide them in 2. So I'm going to use a red pen, and I'm just going to go like this. And so really, they each get a half of that. So I've divided it up. I know B equals 1/2 by doing this, but I don't always think it's as clear to students what this means when we're using division. So I prefer the algebra method on this one to explain it, because I think it looks a little clearer. So with this one, if I'm multiplying by 10 here, I want to divide by 10 on both sides. 10 divided by 10 cancels out, and then we have 5 divided by 10. So they want a fraction answer. They might also take the decimal answer. If you actually did 5 divided by 10, you get 0.5. And we can test this out real quick just to see if they take it. If not, what we want to do is reduce it. Well, they both divide by 5, so it could be 1. 5 divided by 5 is 1. 10 divided by 5 is 2. So we still get the 1/2, just like I was showing with the algebra tiles. We're cutting the algebra tiles kind of in half in order for them to all get the same number. So I'm going to actually try 0.5 and see, does it let me do that? It does. Okay, so it accepted the decimal answer. It would have also accepted the fraction answer on this one. So there's multiple ways to type the answer in here. Okay, so when we're multiplying by a fraction, remember, a fraction means multiplication on the top and division on the bottom. So we're doing both multiplication and division. So I want to undo both at the same time. So what I want to do is I want to multiply both sides by the reciprocal. And what that means is I'm going to flip this fraction over like this. Because 8 divided by 8 is 1. And 5 divided by 5 is also 1. So that leaves v all by itself. So we need to make sure we do the same thing on this side. So in this case, you can reduce first if you want to do the division. You can do 40 divided by 5. Or you can do 40 times 8 and then divide the whole thing by 5. I'm going to go ahead and divide by 5, and I get 8. So 8 times 8 is 64. Because once I've reduced here, I can multiply across the top. But again, if that's a little confusing, you can do 40 times 8, so you kind of go straight across, and then divide by 5 once you're done. So that should, of course, they'll get us at the same answer here. That's the whole goal. So 40 times 8 is 320. If I divide by 5, I get 64. So either way, I arrive at 64. It just depends on if you want to reduce first or if you want to reduce at the end by doing the division. So I just reduced mid-problem because 40 and 5 can definitely divide into each other there. All right, let's go ahead and check that guy and keep moving here so we can finish this problem, or this section here. Okay, so we've moved to a problem that definitely is going to require the algebraic method as opposed to the algebra tile method. You can use tiles with fractions and decimals because we can just do tenths, but I think it's just as, a little easier to learn the algebra method at this point. So I'm always looking to get the variable by itself. So I want to say what's being done to the variable. I'm multiplying by 7. So I'm going to divide by 7 on both sides of the variable there, or both sides of the equation. They do not give you access to the calculator for whatever reason on here, but we're probably a little easier to use the calculator. You don't have to. You can use long division for this one, of course. But, and it wouldn't even take that long because it's 1.6 when we divide this. 7 divided by 7 cancels. So if we looked at the long division here, like this, well, it goes into set 11 one time, right? We bring our 2 down, and then this would be 4. The decimal needs to come up. Well, 7 can go into 42 6 times. So the long division isn't really all that long on this one. So you could definitely do the division part here. But we should have calculators available to us pretty much at all times. You either have your smartphone, or if you're at the center, your center should have calculators. Okay, let's go ahead and check that. And continue. All right, so now we have 6y equals negative 12. So same thing. First question we should be asking is what is being done to the variable? So in this case, we're multiplying by 6. So I'm going to divide by 6 on both sides because that cancels it over here. So y is by itself. Negative 12 divided by 6 gives me negative 2. So I can go negative 2. And again, I can go back and I can check this. I can check any problem that I work out. And if I go 6 times negative 2, I get negative 12. So check, that's correct. That works. All right, continue. 2 more questions here. So we are going to translate this sentence into an equation. It does not say anything about solving this equation. It just wants us to translate again. So we need to make sure we understand those key words as we read. So 55 is means equals. As soon as I hear is, I'm going to write the equal sign. The sum of, sum of, that tells me I'm going to add the next 2 pieces. So it's the sum of 17 and Gail's height. And then they tell me to use the variable g to represent Gail's height. So I know it's going to be addition. That's the sum of, and it's going to be g. So 17 and Gail's height, which is g. I don't have to put it in parentheses. The only time I'd have to put it in parentheses is if I'm multiplying by something. If it says, twice the sum of. Okay, now I need it in parentheses because I'm I'm multiplying both those pieces by 2. But this doesn't say anything like that. It just says the sum of. So this is all I need. So just, again, be very aware of those key words. And if you need more practice with them, I would definitely go, on Google Classroom or, not Google Classroom, sorry, on Alex, and look up that website that I've linked on there. That's in chapter 1. I think it's the second link I have in there. That gives you a whole bunch of the keywords. You can make some flashcards to kind of help you get through. But I would definitely suggest you study those words if you're having any trouble identifying them. All right. So the yearbook club had a meeting. The meeting had 15 people, which is 3/5 of the club. How many people are in the club? All right, so we had 15 people, and that is 3/5 of the entire club. So 15 is 3/5 of, is a multiplication word, the entire club. So I'm going to use C for club. So again, I was able to write that because I understand those key words. So 15 people are in the meeting, that's my total. And that is, again, there's another equal word, is 3/5, so that means 3/5, 3/5 of the club. So instead of the club, I just wrote C, and of means multiplication. So I broke that down kind of quickly, but this is the idea here when we're writing an equation. They don't necessarily want the equation, they just want the number of people. So remember, we're multiplying by a fraction here. It's multiplication, division. I need to do the opposite of both to undo this. And I'm going to do that on both sides here. So 3 divided by 3 cancels. 5 divided by 5 cancels. So I'm left with just C. So now on this side, I can multiply across the top here and then divide by 3 on the bottom. So 5 times 15 equals 75. Divided by 3 gives me 25. If you see the canceling, you can also do that because remember, this is multiplication on top, this is division on the bottom. So I can say 15 divided by 3 is 5, and 5 times 5 is 25. So either way, I land on 25 people in the club here. All right. So that was all of section 2, and I will see you in section 3.